I think we can go ahead and get started. Looks like most people have joined. Hello, everyone, and thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you to the Startup NASA Feature Series hosted by NASA's Technology Transfer Expansion Program. T2X expands the tech transfer mission of ensuring that innovations developed for exploration and discovery are broadly available to the public, to include a focus on entrepreneurial innovation and strategic partnerships that accelerate commercialization. This monthly series is an opportunity for NASA tech-inspired startups to share their experience. This month, we'll hear from Aetherworks, an alumnus of the Expanding Frontiers organization, a federally recognized accelerator and innovation center that fosters the commercialization of advanced space and energy technologies. Expanding Frontiers' mission is to build a robust startup ecosystem in the Rio Grande Valley by providing novel educational experiences and hands-on training for students, veterans, and aspiring entrepreneurs. Central to the Expanding Frontiers program is a comprehensive whole community approach to engage local colleges and universities, school districts, government entities, and private companies through a range of programs. Before we hear from today's speakers, I'd like to point out that microphones will be muted throughout the presentation, so please type your questions in the chat box and we will answer them at the end of the presentation. Thank you. Today's speakers are Hector Valdez and Brandon Neese. Brandon Neese is the CTO of Aetherworks, born and raised in Brownsville, Texas, and received a Bachelor's of Science in Physics from the University of Texas, Rio Grande Valley. He is currently working on a master's in Industrial and Applied Mathematics. Brandon brings 5 years of experience to the startup space, with 3 years specifically in direct air capture of carbon dioxide. Hector Valdez, CEO of Aetherworks, was born in Harlingen, Texas, and grew up in Brownsville. He received a Bachelor's of Science in Business Administration from Boston University in 2011 and an MBA in Quantic Solution Architect and an MBA. He has been a Quantic Solution Architect for enterprise resource and planning software. He brings over 10 years of experience in software implementation projects, 3 years in startup space, and 3 years specifically for direct air capture of carbon dioxide. Hector and Brandon founded Aetherworks with the goal of helping to reduce the amount of carbon dioxide in the environment that is impacting our climate. Aetherworks intends to repurpose NASA-developed technology to create solutions in multiple industries that require CO2 as feedback. With that, I'll hand it off to Hector and Brandon to tell us a little bit about Aetherworks.
Thank you for that great introduction. I just started to share my screen. Is that coming through correctly?
Yeah, looks good.
Looks good to me.
All right, great. So good afternoon, everybody. My name is Hector Valdez, and I'm CEO and co-founder of Aetherworks, and we are capturing and utilizing CO2 for indoor farms. On the call is also Brandon Neese, co-founder and CTO, and he will also be participating in today's webinar. And so for today, I just wanted to go through the agenda quickly before we get started. We're going to be covering how Aetherworks got started. We're going to talk about how a hackathon led to our idea that started the company. We're going to dive deeper into the NASA technology and how Aetherworks is utilizing it. And we'll talk a little bit about the market analysis and our go-to market strategy. And then we will introduce our team and talk a little bit about our next steps for Aetherworks. So the way Aetherworks got started was that back in 2021, I was browsing social media and I happened to find a social media post about Frontiers, which I did not know anything about, but I learned that it was a nonprofit organization with the mission of creating an innovation-driven space economy here in South Texas. And they were having a program where they were going to help develop entrepreneurs and give them the ability to be exposed to NASA technology and potentially license one of these technologies to start a company. And so I got very excited with this opportunity and I applied and got in. And that is where I met Brandon Neese. And we realized we had both joined because we had the goal of launching an environmentally impactful business here in Brownsville, Texas, where we both grew up. And so during one of the hackathons that we had, we were paired together by Expanding Frontiers. They were the method they use is they try to pair a person with a background in business and a background in technology, and then put the different NASA technology in front of you and see what type of spin-off companies you might be able to come up with. And so that's where Brandon and I got connected, and where we were able to identify this technology that NASA had created for carbon capture. And so we both recognize the potential of this technology to address food insecurity and also to reduce an industry's fossil fuel reliance that it had. And so that's how Aetherworks got started back in 2022. And Aetherworks was only capable of being started because it had both Expanding Frontiers as an accelerator and an entrepreneur ecosystem to be able to bring in people who wanted to start a business, and was pairing and bringing in the NASA technology that was available to license. And so in addition, we also, through the process, once we had started the company and we were looking to apply for the license, we worked very closely with Johnson Space Center and their NASA Tech Transfer Program. And so there's all these different pieces that came together to work really well for us to give us the opportunity to have Aetherworks be born. Another important organization that contributed to the funding at Expanding Frontiers is the Department of Energy, which selected Expanding Frontiers as one of 13 companies to be part of a direct air capture accelerator program. And so, we started with Expanding Frontiers and are part of this accelerator. And with the funding of this organization, we've also been able to continue to move forward. So with all those different entities coming together, that's how Aetherworks was able to be born and start. And so the technology that really caught our attention was this technology called liquid sorbent carbon dioxide removal system. And so this was designed by NASA as an alternative to their current system that they used in the International Space Station, which used solid zeolite media to capture the CO2 inside the International Space Station and scrub it out to provide a healthy environment for the astronauts. And so that technology had many drawbacks, like it had high regeneration temperatures, it had to be maintained often, and it also wasn't as efficient in capturing the carbon dioxide inside the International Space Station. So this technology that NASA worked on building was inspired by the technology that's used, has been used for many years inside submarines to scrub the CO2. And specifically, they use a liquid sorbent to be able to capture the CO2 from the air and then be able to provide that healthy living environment. And so this technology was created and designed as an alternative, as a method to be more efficient and be able to capture more CO2 in a more reliable manner. And so that's the image on the right that we see, which is the 3D printed microchannel direct air liquid contractor that was created. And so this is a technology that we looked at and we saw we know there's something we can do with this. So we started looking at direct air capture and doing our research during the hackathon, right, as we're coming up with this idea. And during our research, we were discovering things we have heard before, but we were definitely getting deeper into the details. So for example, since the Industrial Revolution, the CO2 levels in the atmosphere, the carbon dioxide levels in the atmosphere have been increasing dramatically and are now over 400 parts per million. So That is something that's directly impacting our weather today and is being felt by all of us, right? Last year we felt the heat in many parts of the country being different than in prior years. This year is also on track to be the hottest year ever. So we know climate change is a problem, and we are passionate to do something about it because we know it's impacting many different parts of our lives. But one of the most impactful things for us is that it's impacting our food production. So that's something that is caught our eye and why we were interested in this. So when looking at food production and what that looks like in the coming years and decades, we know that by 2050, we will need to produce over 60% more food to feed a population of about 9 billion people. And so doing farming as usual is not going to be, not going to be an option. We're going to have to explore and invest in new technologies. And so with these numbers that we see with decreasing crop yields and increasing prices, this is only going to cause more problems in our society, and these are things that we need to embrace, need to address. And so naturally, traditional farmers started looking for other methods to grow food, specifically, right, to protect themselves against the extreme weather and all the other factors that they were finding changing in the outdoor environment. And so greenhouses had been used already for decades, but there was renewed growth and interest in them. And also in vertical farms, which is a more new process of fully enclosing, having a fully enclosed environment, but stacking up different layers of crops to be able to maximize the use of space within a warehouse, for example. And so these growing methods have many benefits like lower water usage and have efficiency, and they're able to protect the crops from the extreme weather. So these are many of the reasons why there's been a large increase in moving indoors and growing farms indoors. We know that by 2030, there's going to be vertical farms are going to be valued more of about $27 billion as opposed to $4 billion just 2 years ago. So there's tremendous growth in this area. But with that growth, there's also issues that we're seeing and what we were looking to address. And so now I'm going to pass it over to Brandon, who's going to talk a little bit about the carbon dioxide problem with indoor farms and how Aetherworks aims to provide a solution.
Hey everybody. So first, I want to talk about why CO2 is important to indoor farms. Because right outside, we saw the climate change caused by CO2 causes damage to crops, but it's the opposite indoors. If you have the right environment inside an indoor farm with a CO2 or carbon dioxide concentration anywhere from 2 to 3 times what you would find outside, plants actually tend to have an increased yield or grow faster or grow bigger up to 30%. So there's a big advantage to actually using CO2 indoors. And another thing, just like in a big office building, skyscraper, or a school or something like that, where there's a lot of people, oxygen level tends to decrease. Same thing happens in these farms for carbon dioxide because the plants breathe the carbon dioxide to grow. So what a lot of farmers do is to supplement the CO2 loss that the plants intake and to increase their crop yields, they burn natural gas or propane inside these farms to artificially increase the carbon dioxide levels, which is absolutely insane. So when we were looking through this whole what kind of market to use this technology with, or how can we address climate change, it's insane that you can get 540 million tons of CO2 globally are just being released by these indoor farms. And to compare that, cattle and livestock is like about 4% of greenhouse emissions. So this is even more than livestock. All because we want to have a better yield rate and to be able to avoid crop loss caused by climate change. So this is one of the big factors into moving indoors and supplementing CO2. Can you go to the next slide? So our solution is we want to eliminate the use of fossil fuels and offer a on-site clean, renewable source of CO2 directly from the atmosphere. So the idea is we would use this technology that was used to sustain life meant to sustain life in the International Space Station, and use the same properties and attributes of that to help sustain plant life and help it thrive inside an indoor farm. So there's a lot of greenhouse gas emissions that could be eliminated yearly with this technology. You would eliminate any kind of interaction between like the transport. So if you don't have to transport fuel or gas to the farms, it's all going to be on site. So you can get rid of the greenhouse emissions from any kind of transportation. And right now we are designing something similar to what's on the space station with some modifications for it on Earth. So one thing that we noticed, and I'll get into when we look over some of the data and the experimentation, is the sorbent that we use, diglycoamine, loves carbon dioxide. It has a huge high affinity for carbon dioxide. But the unique thing about this is that it also has some affinity for acidic gases. So a type of an acidic gas that's commonly found in the atmosphere is also water. So our solution, we want to tie in something that can supply CO2, utilize atmospheric water, and if we can control a heating component, we're going to have a complete environmental control system designed for an indoor farm for optimal plant growth, because not all plants grow at the same temperature or humidity either. So by optimizing these three parameters, you can really optimize your growth yields for your crops. And it's very crop specific in the greenhouse. So that's the whole point of building an isolated area, and you put one type of crop in these greenhouses, and then you optimize the parameters for that crop. So if you want to grow multiple crops, what the farmers do is they like to put different greenhouses with different crops. So one greenhouse might have just pure spinach, the other one might have pure basil or mint. And sometimes if they're similar enough, you can put them together, but it just depends on the type of crop that you're growing. Next slide, please. So how did the technology work for NASA? They have this 3D printed contactor, and the sorbent would sit on it, and it would pull the rich sorbent down the capillary and pull it the lean, or once it desorbed. So in this case, a sorbent is a liquid that absorbs carbon dioxide in our case. When the liquid absorbs enough carbon dioxide, it gets sucked down the channel where it's meant to get released. Once it's released, it goes back up the channel based off the different densities and other properties. I'm not exactly sure. It has to do with the fact also that's in microgravity. So this was a challenge that we had, was how do we adopt this to on Earth use? So we had to play around with the technology a little bit so that we can optimize its performance to work in gravity. So thanks to the startup license, so we went through a few phases of licensing, and our first one as our company, we started with an experimental license. With this license, with the tech transfer, we were able to actually have conversations with the inventor. So before we started doing any testing, I was able to get a list of questions, give it to the inventor beforehand. He would answer as many as he could, or can answer. And then we had a meeting, we were able to talk. It was really productive. It was Dr. Graff, very awesome guy. And based off of our conversations, we designed a tabletop prototype to prove the concept can be done on Earth, not just in microgravity, and test some ideas of how we can start implementing this into greenhouses. So if you can go to the next slide. This was our tabletop setup. So essentially, we start with lean sorbent that moves into a tank that is going to be just essentially would be our outside or atmosphere. So we have a plate that helps with the surface area and the interaction between the sorbent and the carbon dioxide, so we can try to optimize that absorption. Once we absorb the CO2, it's going to get pumped into the CO2 release chamber. And there we would measure how much CO2 gets released, and we'll do it based off the volume of how much air is in the initial tank to try and see how much CO2 gets released in the release chamber. Now, one thing to note, and this is where we started noticing about the humidities, in the absorption chamber, you can see humidity build up, and in the release chamber, it's building up a lot more. So that's where we started realizing that we can start playing with humidity with our technology. But that came after experimentation and doing more research. At first, we were only interested in just applying CO2. So this has really been coming together as a technology for indoor farms. So if you go to the next slide, please. This is what we got, or you could see on that laptop screen that was there. So over the course of 30 minutes, the main thing I want to focus on is kind of pretty much between 1500 and 2000. I just kept cycling the sorbent in that first chamber. I wasn't sure when it would get saturated or not. And when after about 20 or so minutes, I thought, hey, this is probably good. I would think it would be all absorbed. And I moved into the next chamber. And the sorbent, I maybe used a little, like about 500 liters of it or so. It's not much. And I thought it would have been fully loaded, like it wouldn't be able to absorb any more CO2. But as soon as I put it in the test chamber, you see it dips even more, which means before it started releasing carbon dioxide, it absorbed all of the carbon dioxide in the test chamber. And then once it released, it jumped to about 9 times you would see in the outside atmosphere. Which tells me that this sorbent has a huge affinity for CO2, and that it was actually preloaded before with carbon dioxide before testing. So that helped us also know that we need to release the sorbent before we start cycling it in any kind of test chamber. So it effectively was like if we didn't have a chamber on the first one, it was just like almost an open air. And then we released it into the chamber. But this was what we wanted to see. This was like the greatest proof of concept that we can do, because this showed that we can capture carbon dioxide out of the air using this NASA technology. And now we just are going to be working on a prototype, which should be completed this summer to be tested in the field on an actual farm, based off of this concept and this initial lab testing. So I'm going to send it off back to Hector.
Yep, thank you, Brandon. And so in parallel, as we were doing the lab testing, prototyping, we were also going out and doing market research and validating with potential customers that there was indeed a need in the market for this type of technology. So from our estimates, we calculated that roughly 1.4 billion globally is being spent on CO2. And that number is expected to increase as the indoor farming market continues to grow and is projected to grow from 36 billion to 75 billion by 2028. So there is a large and growing opportunity for Aetherworks. And so in addition, right, we reached out to different potential indoor farms and greenhouses as we were performing customer discovery, and we found that, there was, very similar things that the customers were saying. The general theme was that customers were looking for a better way to add CO2 inside their indoor farms, and that they wanted it now. So, right, many of them were ready for a prototype, and we're not ready yet to deliver one. So it was exciting yet very difficult position to be in, because we had an opportunity immediately, but we weren't ready yet to provide that prototype unit to them. And so with knowing all that information that the market is there, we started working towards our go-to-market strategy. And since that first lab prototype, we've built an additional field prototype that we've been working on and testing over the past couple months, which we hope to have ready by the summer to be able to then put out into the field to be able to test and gather more data on it and continue to tweak it to make it as efficient and productive as possible. And so from there, we're going to take those learnings that we're going to get. We're going to continue to tweak our commercial design so that we can have that wrapped up by the end of the year and start looking at producing our commercial unit by the end of the first quarter of next year. And so here's a team that's been working hard to make this dream a reality. And so Brendan and I have already been introduced. So I'm going to go ahead and jump over to Jim Weir, who is an experienced mechanical engineer with many years of rapid prototype development and experience in the oil and gas industry. Alex Romero has worked with us as a research analyst and helped us connect to many of the clients that we have reached out to and had very insightful conversations with. In addition, we have our team of advisors that have helped us along our journey. Dr. Frederick Jeanette, who, as was mentioned in the beginning of the call, is a founding director and executive director at Expanding Frontiers. He gave a talk here on this series a couple months ago, talking about all the great things that Expanding Frontiers is doing. We have Jane Lee Hicks, who is the acceleration director and has over 20 plus years of helping startups scale and reach profitability. Through the Expanding Frontiers network, we were able to be connected to additional advisors like Dr. Anjali Gupta and Bob Milner, who have both extensive business experience and also startup experience backgrounds. And so they have been invaluable in giving us advice and helping us through our journey. And so, as Brandon was also mentioning, one of the major benefits of having the NASA's license is that having the ability to speak with the NASA inventors and ask our technical questions and be able to have very insightful conversations. And so that has been extremely, extremely helpful for us. So as we continue on our journey, we're actively looking to connect with new customers who are interested in a cleaner and cost-effective way of supplementing their CO2 requirements inside their indoor farms. We're additionally continuing to look for funding opportunities and applying to grants. We are also looking to strengthen our team and become more well-rounded by adding a chemical engineer to the team. We are also looking to connect with manufacturing partners who would be able to help us build and scale our product once we're ready to have our commercial product ready for the market. And so, in summary, we can no longer ignore the carbon dioxide and food insecurity problem we have. And Aetherworks is providing a solution to help increase the crop yields while also decarbonizing the agricultural industry. And so we will be very excited to talk to anybody who's interested, and please reach out if you're interested in joining our mission for a better tomorrow. Thank you, everybody.
Thank you both. We're going to move into the question and answer section. Thank you, everybody who has already submitted their questions via the chat box, and please feel free to continue to do so as we're talking through these. All right, so Hector, Brandon, I'm kind of just going to pull the questions out of the chat box, ask them to you, and we'll kind of move through them that way.
Okay.
Okay.
Okay. First question, how does Aetherworks ensure the efficiency, safety, and sustainability of the CO2 capture and release process within the indoor farming environments?
So the unit is going to sit outside the greenhouse, and all the desorption process will happen outside. So the unit will filter out ideally just pure CO2 or with CO2 with H2O, and that will get streamed into the greenhouse. So there wouldn't be any worry about the chemical sorbent being inside the farm at all. The process that how we're going to regenerate is very low heating in this case, but we're also looking at different techniques, which is part of some of the grant applications we're working on, which will minimize any kind of degradation of the sorbent. And DGA itself has it has no VOCs, I believe what it's called, or some of the contaminants.
Mm-hmm.
I believe that I don't know if I missed any other aspect of the question there.
No, I think you got it. Okay, could this technology, once matured on Earth, be slightly modified to have a functioning greenhouse on Mars?
Yep. So that's been one of our longer term goals, to also be able to take the technology that was first designed for the International Space Station and be able to find a use for it here on Earth, and be able to scale it and learn more about it, and potentially then be able to also take it to Mars and take advantage of the needs that will be needed over there in terms of food, the food requirements, and be able to find a way to also have this technology provide benefits once we're at that point in time. So that's definitely something we've had conversations about, or would be very, very excited to be able to be part of that journey.
And I'll add on top of that real quick. And yeah, if you have humans living inside structures, we could reuse the CO2 humans breathe out to feed the crops potentially. So yeah, it'll be modifying the idea about it, but it's definitely a potential.
Awesome, thank you. And just a quick housekeeping note, I saw someone ask in the chat if this will be recorded. Yes, it will. It'll be up on our YouTube channel in the next couple of days. And I'll see if we can drop a link to that channel in the chat box. Okay, next question. Can you discuss any unexpected discoveries, adaptions, or challenges that emerged during the process of licensing the patented technology and applying it to your solution?
Yeah, I'm trying to think. And so there was any challenges or any?
I can read it again. Can you discuss any unexpected discoveries, adaptations, or challenges that emerged during the process of integrating the NASA patented technology into your solution?
I have one. So when we're capturing the carbon dioxide, once the sorbent captures a little bit of carbon dioxide, it likes to absorb water also after that. So if we can control how much it stays on the sorbent as you cycle it, you can get a combination of CO2 and water, which was something we didn't realize was a potential when we first looked at this, like during the hackathon. So as we were growing through our company, this is something we discovered and working with this technology.
Yeah, and another thing I'll add is also, we went through multiple iterations of ideas that we thought of how we could translate the designs that were on the patent to on-Earth use. And so, it's one of those things where you have to, do multiple iterations and make tweaks as you go, as you learn more things. So that's something we experienced.
So, can you talk a little bit more about your experience with Expanding Frontiers?
Yeah, absolutely. So like I said, we had joined their Entrepreneur in Residence Apprenticeship program back in June 2021 program, and that program gave me a lot of insights and learning about how to start a startup company, and also while being able to be part of these hackathon weekends where we would explore the different technologies and find ways to translate them to on-Earth use. And since then, they've now started an accelerator program. So any company that goes through their Aero program and has an idea that they want to move forward with, they could become part of the accelerator program, which also has provided us with many resources and support as we've been moving forward in our journey. Brendan, I don't know if there's anything else you want to add.
So in the actual apprenticeship program, we learned almost anything you need to know to be an entrepreneur. There was so much information. Thankfully, everything was recorded. That it just was an abundance of knowledge, like exact company formation, types of formation, stock types. Just they got a lot of great speakers and advisors to come talk to us and mentor us about different aspects of what it means to run a company or structuring it, things like that.
Yeah, and in addition, it's one thing also that, having an organization like that here in Brownsville, Texas, which in the past hasn't had many type of support for any entrepreneurs, was just something that when I left for college and ended up coming back, seeing that organization existed and the programs they had, I was very surprised and excited once I became part of it.
Great. Kind of piggybacking off of that, can you talk about the regional significance of having this organization kind of around the Brownsville area?
Yeah, historically, Brownsville was a underserved community, so many of the people in the community don't really have or don't see themselves or think there's an opportunity here to aspire to be an entrepreneur or starting their own business. They usually just go straight into manual labor, trade labor. But with this and the outreach Expanding Frontiers has been having with the local schools and community, there has been a little bit of an opening of, hey, there's this great opportunity, especially locally, to get into some kind of entrepreneur or starting your own business. Even if there's no direct translation of tech to business, the skills you learn from Expanding Frontiers and structuring and operating a business will go for anything that you wanted to do in terms of, being your own business owner.
Thanks. In terms of scalability, do you see opportunities for this technology to be scaled up from its the current way that you're planning to use it, or maybe scaled down for personal in-home use as sustainability becomes more and more of an issue in terms of like new builds and homes?
Definitely, this is scalable. You can put multiple units together in junction to, supply a big building or farm with CO2. And I've even joked around with Hector a little bit that we need to make a small version so we can have our own carbonated soda machine at home that uses the air inside to get the CO2 to carbonate in. So yes, definitely it's scalable, but it's just it depends. It's really what your demand of carbon dioxide is how you would want to approach it, the problem.
Okay.
Yeah, and in addition, we're focusing on the indoor farming market as our first market that we're trying to introduce the product to, but there are many other markets that also have CO2 as an input. And so there are many different types of industries that this technology can also be transferred over to. And so that's also something that we're actively exploring and keeping our eye on for having many use cases for this technology.
Awesome, thank you. And final question that we ask everybody on this this webinar series is, what advice would you offer to other startup founders now that you've gone through a little bit of it yourself?
Good question. Yeah, it's a journey, and there's ups and there's downs, and there's different types of challenges that you might run into depending, if it's the technology that you're working with, or if you're trying to find the right market and how to market it to your customers. But one thing is that you have to have a plan and stick to it, and also be able to find the right team that you can work together with and get that support, because it's very difficult for one person to do it, and you need to reach out and find the right team who's also passionate about the problem you're trying to solve. So I think that's my recommendation.
Yeah, I agree with Hector. I was actually part of another startup before this for water purification, and the reason why we fell apart was because we classed ourselves and had a disagreement, and the whole thing fell apart. So having a good team and people that you can get along with is good. And I would also say be perseverant, because it's gonna be things might not go always your way, like Hector was saying, or things might take a long time, and you just gotta persevere through it. Because from what I've seen over these past years is that we've moved forward and at a very good pace, and it's just about being patient and seeing it through.
Awesome. Well, thank you both so much for taking the time to share about your company and your startup and everything you've been through with this audience. I hope everybody online enjoyed listening to this, and the recording will go out within the next couple of days. And do check out our past webinar with Expanding Frontiers if you're curious to learn more about that organization. Hector, Brandon, thank you again, and have a good rest of the afternoon, everyone.
Thank you very much for giving us the opportunity to speak.